class, this is Mr. Watlington, and welcome to Chapter 8. We're in Week 6. This is Chapter 8, System Acquisition and Development. I just got a few slides for you. Like I say, I will be honest up front, this is not my strong suit, but we're going to go through this anyway. So what we're going to talk about in this presentation, in this lecture, well, it's the software development lifecycle, SDLC. And then we're going to look at some software models. We're going to look at the waterfall model, spiral model, the agile, and the software capability maturity model, ideal. And we're going to also look at CI and CD, what we call continuous integration and continuous delivery, as well as continuous deployment. Now, I know some of these models were covered in the PowerPoint presentation that was provided, so that's why I wanted to open up a couple of different models as well. Now, when we think about models, there's some commonality between all of them. And the way I always like to present this is from this perspective is kind of the basic core of any development model. And these are the common development processes that you're going to see. We're going to walk through these. Conceptual definition, functional requirements determination, control specification development, design review, code review and walkthrough, system test review, and maintenance and change management. Okay, so let's get into these. So the first thing when we start any type of project, whether it's software or hardware, but we're focusing on software, is what we call concept development. You have to really nail down the basic concept, and really it's a couple of paragraphs of a statement of what is the stakeholder, what is the customer really wants. And trust me, guys, this is where we really lose it and miss the boat a lot of times, because we're all looking at things from different angles. A software developer is looking at it from one angle, software engineers, software analysts, we all have our different takes on these. But really at the end of the day, I can say this word, I'm sure I can, end of the day, if we're not careful, we will miss really what the customer is trying to tell us. And so that's why when we talk about a concept definition, we always want to keep it as short and succinct as possible. Capture what the customer's needs are very succinctly. 1 or 2 paragraphs is all you need. So now, after you go from that step, now you're ready to move into your functional requirement determination. That is, once the stakeholders have all agreed on what the concept statement is, so now we can start looking at some other components of our process. We start looking at our business requirements, user requirements, system requirements, and we want to be sure that they all fit together, because many times it's so easy to outrun our headlights to where we're starting to make user requirements and we really haven't linked it back to what is the business's needs. At the end of the day, it's about the business, it's about the organization, it's about the customer. And so once we develop the business needs, now we can move down this pyramid to the user requirements, meaning who are the people that's going to actually use this system day to day. And from there, we develop system requirements. But all too often, we back into this. Whereas we buy a system, because either, especially as many times when our C staff, they go out, they hear all these fancy briefings from salesmen and from business development guys who make all these great promises about these systems, and now it's, hey, look, we want to buy this system because they just told me this is the best thing since sliced bread. Not knowing that, well, yeah, true, maybe a great system, but it may not meet our users' requirements, and likewise, it may not fit into your business objectives or your business requirement. So that's why you always want to keep this top-down driven, that you look at here's my business needs, this is the user requirements, and now I can integrate my systems requirements into that. Now, at this point, especially for cyber, and this is the piece that I always like, I always talk about cyber as let's bake it in and don't strap it on. And that's what I mean. And because for engineers, many times what we want to do is develop, and we'll take care of the security stuff later. Well, that's how we got into the situations we are now with a lot of our protocols and a lot of our networks, is that security wasn't thought of up front. So when we look at our cybersecurity footprint, we want to bake that in early into the process. And the things you always want to look at is confidentiality. You want to be sure that the system maintains confidentiality of vital data. If you remember what last week, I think it was, last week, week 5, we talked about cybersecurity, and we talked about the cybersecurity triad: confidentiality, integrity, and availability. So you want to be sure that you build those three things in, as well as availability and fault tolerance. What I mean by fault tolerance is how much risk are you able to afford if your system goes down? And we build fault tolerance in many times by replication, meaning now I have multiple servers, I have my information backed up multiple places, or I may use a cloud service, to provide fault tolerance. So if one server fails, there's another one right there to back it up and come right back online. So when we think about these types of things, we want to be sure our information is confident, remains confidential, that we maintain the integrity of our data, and also that it's available. So bake it in, don't strap it on. Now, from there, we're ready to go into what we say a design review. Like I said, this once the functional community and all your control specifications are met. Now you can let the system designers, they can get busy doing their thing. Now, sometimes this can be a lengthy process, really can be, when we're talking about design reviews, because many times you break it down into modular. It's a modular process. And really, this is where you start laying out timelines. You start bringing your teams together so that you can start meeting your timelines, your milestones for your coding. So as you're starting to write code, as your developer starting to write code, now this is when you process improvement, project management, all those skills start coming into play when you hit that design review section. Now, if you got code written, you want to do a code review. So we've gone from a design review now to a code review. And here again, that happens after the stakeholders have given the software design the blessing. All right, design is good. Now the coders start coding, but now really that's when project management really kicks it up another notch. And that's when you start scheduling your code reviews and code walkthroughs. Now, I like this little cartoon because I think this probably happens in a lot of our organizations. Okay, you got a submitter. Okay, he's going, well, I don't have to worry about this too much because I'm sure that the programmer did a great job of writing it. So, and I trust him. Well, the reviewer is going to catch it, So if I can write pretty sloppy code, because somebody else is behind me is going to be looking at it and they'll catch the mistakes. The reviewer is going, well, you know what? I'm sure that the code writers knew what they were doing. They're smart people, so I don't have to really dig too deep in this. So what happens at the end of the day? We end up putting out sloppy code with a lot of mistakes because nobody is really reviewing it. So you want to be sure that if you're a project manager or if you're probably a systems analyst, that you kind of look over the shoulder of this process pretty well, because there's a lot of places for error in that step. Now, after we do that, now we're ready to go into testing, some type of user acceptance testing. Excuse me. And really, especially with software, a lot of times they know we go into this knowing that there's going to be some errors, knowing there's going to be troubles. As a matter of fact, a lot of your commercial off-the-shelf software now, we are the consumer. We are their testers. That's why they have, hey, would you like to participate in our quality improvement program? In other words, they're saying, we know we wrote some crappy stuff, and hopefully you'll catch the errors and you'll send us back to us, with a little, in our database collection tool. So, that's kind of what they're saying there. So as we go into user acceptance testing with software, with code, knowing that there's going to be things there that we're going to have to fix. But, all right, now, so once you make it through that process, you get the thumbs up, yes, thumbs down, no. Hopefully you get thumbs up, yes, with this many errors and this many deficiencies that you have to correct. So you need a plan of action and milestone and a deficiency chart so you can track your deficiencies and get those closed out on your, what we call a POAM, your plan of action and milestone charts. So, but once we get there, now we're going to start deployment. We're ready to get it out to our customer. We're ready to get it out to our organization so we can start, so that our users can get hands-on and start using it. So now the system's operational. Everybody's happy. They're high-fiving in the hallway. But really, I'm telling you, this is really probably one of the most laborious parts is maintenance and change management. I tell you, change management especially, it can be very rigorous, but very important that you have some type of configuration management, CCB, a configuration control board. You need some type of configuration control and management process. So that way you can track when changes come in, how changes are made, and be sure a change here doesn't disrupt something else over here. So you can look at how your software is being updated in a post-production and pre-production environment. Okay, and so as well as maintenance. How do you do maintenance updates? How do you use software updates? Because there's going to always be updates, maintenance required, as well as change management. So now we've kind of walked through that standard process. Now, actually, no matter what kind of model that we use, we're going to talk about these, you're going to see a flavor of that SDLC woven throughout. Now the names may change, the titles are different, but you're going to go from that concept development, and you're going to go from there all the way down to where you do maintenance and change management. All right, so what we got? Let's talk about the waterfall model. This is one of the early models. A guy named Winston Royce in 1970. He was the one who introduced and developed this model. And what this model is, like I say, they call it waterfall because each phase waterfalls down to the next phase, but you also have a feedback loop where you can come back. So it's a pretty relatively sequential. Now, one of the things that the drawbacks of a waterfall model typically is if something happens here, it doesn't automatically always feed back into here. So it can be because it is linear. Now you're looking at, if you put a timeline along the bottom, this could be quite a bit of time before from concept development to deployment maintenance. And many times what happens, by the time your code actually gets out from this end to here, to the maintenance area, it's already outdated because it has taken so long for it to go through the stages of this waterfall model. So that's been one of the drawbacks of the waterfall model, especially as the desire to get software to the field quicker and quicker and quicker. So what kind of a variant on this waterfall model is what we call the spiral model. Now, and what we have here is prototypes. So if we start here in the center. So we go around one time in a spiral, and right here, this is P1, that's our first prototype, our first software prototype. And then from there, as we go into a development and verification stage, and we come back around and we determine what new objectives and what new other constraints is in that prototype, and we come back around to where we evaluate different alternatives and try to identify risk, and then we build prototype 2 in this section. And you just keep this spiral going until hopefully, maybe third prototype, fourth prototype, but at some point where you have usable software that now you can deploy and deliver to the field. So that is the spiral. But as you see, it still follows somewhat of, even though it's still circular, it still follows somewhat of a linear step-by-step process as we build the prototypes out. So like I said, just a variant of the waterfall style. Now, what we see today a lot is the word agile. If you've been around anywhere, at any period of time, everything is agile, and scrums, and all of these different new terminology, scrum masters, and I don't know, I feel like I'm in the Lord of the Rings movie sometimes. But what agile software development is, it's a way of really speeding up this process, and not really like the waterfall that was pretty rigid, step by step by step. Agile is a lot looser. Like I say, it began in the mid-1990s. Like I said, they really were. The software development was trying to break out of the rigid models and looking at how to get capability to the field, capability out to the customer, to the stakeholder much quicker. So if you kind of look at this process over here, where we start, like I said, where you initiate a process, a project, and you've defined your requirements. Now it starts to go into this agile development loop of where you integrate, and test. There's continual. Now here's the key to agile right here. You have continual visibility by the developers, the users, and the stakeholders, or the clients, the end users. So now before, and you may hear this also called DevOps. DevOps is kind of a variant off this, where we talk about development and operations, collaborating and working together to produce a product. Because typically in the past, like especially with the waterfall, you get together for your concept development with the customer. Okay, once, and then we all sit at the table, we do a group hug, okay, we got it. And then, the developers and the engineers, they scurry off to a back room, never see the customer again until it's time to do what? Yeah, exactly, to do the user acceptance test. But, so if there were problems there, a lot of those weren't caught. But now with Agile, we got this teaming, and they're constantly monitoring each phase of this integrate, test. Now we get here, and if the product is good and the customer is happy, we can deliver it. Boom. But if not, we come back around and we record what the problems are, we do our adjustments, and then we start our next iteration of developing that. But so now it's a very agile process, and we want to start being able to just push software out to the field quicker, and knowing that things is in constant change. As a matter of fact, when we think about Agile, we always have to think about what we call this manifesto for Agile software development. It's 12, it's like 12 steps to this manifesto. And some of these are very different for a way of thinking for process engineers and people of that nature. But you know what? It works because now even outside of the software world, you have other industry that is looking at this agile process of how to break some of the paradigms that we've been in with this development of software, hardware, system components. So if you look at the first one, it says what? Our highest priority is to do what? Satisfy the customer through early and continuous delivery of software. I want to get it to you early. I want to continue to get it to you. So it's not like I'm going to wait to try to build the perfect software to run through all these wickets. I'm just going to get you a module at a time. Here, this works. This works. I'm going to come right behind that with a continuous improvement. Here's the next iteration. So while we're making changes, the customer's already using the software. So it's not like they're waiting 5, 6, 7 years to get software. Here it is right now, 1 year, 6 months, 2, 3 weeks. You're getting a product that you can work with. And because customer requirements change, and that used to always be the problem, was what we used to call requirements creep. So meaning that, okay, we had our concept development phase, we all ran in the back room, we started working on it, then the customer went, you know what? I would also like to be able to do this. And then we go, well, no, you can't do that because we've got our contract, everything is set in stone, you can't change anything, and we're going to give it to you, and that's the way it's going to be. And the customer goes, wait a minute, but this is what I need to do because technology has changed, everything has changed. Now, when we first started this process, I didn't know about JavaScript, we didn't know about wikis and blogs, and all these things. So now I want to integrate these. So this is where this comes in. So now we can turn those changes in quickly. Second one, welcome changing requirements. Kind of piggybacks on what I was just talking about. Even late in the development process. This is before where the developers, coders would be pulling their hair out. You mean, wait a minute, what? I've been writing code all night. I've drank, 2 6-packs of Red Bull, and I've been taking the little shots come in the bottle, energy drinks all night. And now we got to change? Yes, embrace it. Embrace the change. Whereas before, we fought it. And now with Agile, embrace it. Because really, because that's what gives your customer is that competitive advantage, getting them the stuff when they need it. Third one, delivering working software frequently. Like I said, but now we're talking within a couple of weeks or a couple of months, as opposed to where it used to take years to get software. And by the time think about software, if it takes you years, it's already outdated when they deliver it. It says the business people and developers always work together daily. And see, that's very different, especially in the environment I used to work in with the DoD. We would get together maybe at the most quarterly, usually maybe annually, to do program management reviews or program design reviews. Now you got the customer and developers working together lockstep daily. Number 5 says what? Build projects around motivated people, motivated individuals. Give them the environment to support their need and trust they'll get the job done. I think that stands on its own. I don't have to say any more about that. Number 6 is what? The most efficient and effective method of conveying information to or from a development team is what? Face to face. Now we say face to face, but we're also talking about collaboration tools. Things like Zoom and all these other now we can collaborate, but it's still face to face. It's not just sending a document with changes on it that they send back, and we go back and forth with this document over email or sneakernet mail. Now it's face to face. We capture everything right there where we need them. Okay, number 7 is what? Working software I like this, working software, not schedule, not cost, not time. If you think about typical project management, those are the measurements of success in a typical project, cost, schedule, performance. Now, the working software is the measure of progress. Working software, the end product. Number 8 says what agile processes promote sustainable development, meaning that once you get in this agile circle, that cycle, it should be sustainable to where your team can sustain that, and you're not burning them out, you're not running them in the ground. Number 9 says what continuous attention to technical excellence. That's where you still continue to embrace new ideas, develop your team, invest in your people so that they become technically excellent. I love number 10, simplicity. Sometimes when I teach, I always try to tell people, maximize the simple, make the best out of the simple stuff. The art of maximizing the amount of work not done is essential. So what steps do we not need to do so we can speed the cycle up? It says what? The best architectures, requirements, and designs emerge from self-organizing teams. That very loosely coupled teams, not just a strict org chart. Here's the org chart, and Johnny, you're going to work with her, and he's going to work with you. But no, let those teams be able to self-organize and self-merge. And sometimes they'll morph and come back out this way. And because that's where now the team works together, and you really get collaboration and good use of your human resource. And number 12, at regular intervals, the team reflects on how to become more effective. And then they tune their processes to meet that. So there we go. There's those 12 aspects of Agile, or the manifesto of Agile software development. And really, if you think about it, when you read these, isn't it something that we as humans, we as Christians, shouldn't we be kind of striving for those same things? Excellence, understand the simplicity of the gospel, always be more effective in how we spread the word, how we minister, how we witness to others. Our primary measure of progress should be what? Not how much money we raised, not how great the choir sounded today, not how eloquent the pastor sounded, but what is the measure of progress for a Christian? That's right, salvation, spreading the gospel, getting the good news of the gospel, people being saved. Sometimes we lose sight of that. All right. So let's take a look at our software capability maturity model. Carnegie Mellon University introduced this SW-CMM. And what they are saying is that an organization's they mature. There's a maturation process, and they broke these out into different levels. As you develop software within an organization, that you move through these phases sequentially. Some people agree, some don't, some follow this. But you look at level 1. This is your initial stage, and really at that point, your processes are unpredictable, poorly coordinated, and you're very reactive. Now, as you mature to level 2, now you're what they call managed. That's where your processes are becoming more like projects. Instead of now just ad hoc processes thrown together, now they become projects. And you starting to get project managers, but you're still reactive. You hadn't gotten ahead of the power curve yet. You get to level 3, where we talk about define. That's where your process is characterized for the organization. Now you're starting to streamline processes, things are becoming more efficient, and now you've got the ability to start becoming more proactive. Why? Because you've starting to train your team better, you've gotten better resources, you've gotten all these things now where your processes are being streamlined, you've got process improvement going on, so now you're starting to get there. And then as you look at, level 4, that's where you become quantitatively managed, what they call. That's where you're actually able to go back and start measuring and controlling your processes and really bringing those things within their boundaries and really making money there. And at the top level of that, now when you've reached the utopian level of maturity for software is optimizing. And now that's when we're focusing on what? Process improvement. So this is their claim that organizations who develop software go through these steps, these maturity levels. Now, they also came up with another model called IDEAL. And if you look at IDEAL, here we go, here's what the acronym IDEAL means: initiating, diagnosing, establishing, acting, and learning. Kind of saying the same thing, isn't it? Just a different way of looking at it. It takes you through these 5 phases of maturity, really, even though it's not a maturity model, but basically it is, where you start with project initiation, then you diagnose what type of problems, issues you may have, and the next phase is where you start establishing, or you start doing diagnostics or recommendations from your diagnostics, and starting to develop your plans of action, so your POAMs. Here, acting, like I say, that's where you really start talking the talk, like I say, and walking the walk. And then learning is where it's the feedback loop, which is really going back to the process improvement phase. So we've talked about these different phases, these different models, right? And you see that they all have a common thread of going from, like say, concept, definition, all the way down into where you're able to now to do process improvement, change management, and maintain maintenance of the equipment, of the software. Now, one of the hard parts though is still delivery. How do I do integration and delivery? Now, these 3 terms, continuous integration and continuous delivery, continuous deployment. So when we think about continuous integration, that kind of goes back to our agile model. So you see here in continual integration where you build, test, and you keep that cycle where you're continuously integrating, building and testing into your software. Now, continuous delivery is after you've got your continuous integration circle going, now you're ready to start going to acceptance testing, and you deploy to what they call staging, and then you're ready to deploy to production. And from there, you just what's called smoke test, where you do your user acceptance and users start to use the software. Now, in the continuous delivery, your delivery is done manually. For instance, like you think about Microsoft, where they have, Patch Tuesday, meaning that they go through this process, but then every, second Tuesday, that's where they push out their new patches, their new updates. And most software organizations, they're on a cycle like that. That's when they're going to push out their new updates, new releases coming out. Whereas continuous deployment is very similar to continuous continuous delivery, but the difference is deployment is automated. It's an automatic thing that we're not waiting for a certain date to push this out. Now, as you do continuous integration, we can do continuous delivery, which, like I say, is a manual delivery. Or we can move into continuous deployment, which is automated or automatic delivery. There we have it. Okay, so let's summarize what we talked about today in this lecture. We've really kind of skimmed across the top of the system development lifecycle. And this development process, like I say, it works for software, it works for hardware, firmware, many different things. And we looked at some different SDLC models. We talked about the Waterfall Model, Spiral, Agile, the software capability maturity model, as well as IDEAL. Then we ended up talking about CI, which is continuous integration, CD, continuous delivery, and continuous deployment. Hey guys, thank you very much. Like I say, if you have any questions, as always, just a text or email away. Hopefully this helped you out a little bit with Unit 6, and Week 6 with Chapter 8, and I've also have a video on Chapter 9. All right, God bless you. Have a great week.